This is a bonus video. Excuse me. This is how your calculator and your computer will solve it, and it's one of the reasons why linear algebra is really useful for computer science. It is really where the rubber hits the road for a lot of mathematical solutions and applications. So this is Cramer's rule. It's not really a rule, it's an algorithm. We can think this rather splendid looking guy, Gabriel Cramer, who I think was Swiss, for coming up with this in around about 1745. But again, a lot of it is Gaussian. So the algorithm is this. First thing we do is we get our simultaneous equation into a form. We have all the x's, all the y's, and maybe to the side all the constants. If you recognize these are the same simultaneous equations from the last video. Then what we're going to do is we're going to take the coefficients of the numbers in front of those there, and so the coefficient of that is 1, the coefficient of that is 1, and we're going to copy just the coefficients down. 1, 1, 2, 3. And then we're going to copy down the constant term, but it has to be in this form. So it has to be something x plus something y equals some constant term. So far so good. Then what we're going to do is we're going to find what's called the determinant. I think that's how you spell it, of this matrix that we've set up. And the way we do that, it's going to be this times this minus this times this. So Cramer's rule is great because it always gets you an answer. There's no art involved. It's always you put in those numbers, bing, 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 bing. Out pops the answer. That's why it's so great in computer science. So I'm going to copy x and y. And I'm going to put a line there. You'll see why I'm doing that in a second. So let's find that determinant. 1 times 3 is 3 minus 1 times 2. Hopefully you don't need a calculator for that. 3 minus 2 is 1. So far so good. So our determinant there, we're going to put 1. Excuse me. Okay, now comes the tricky bit. What I'm going to do, I'm going to get these two numbers here, and I'm going to sort of cut and paste over the top of the 1 and the 2, the x, and by doing that I'm going to solve for x. So let's do that. Let's actually just copy this down. Let's do it next to Miss Cramer. So instead of 1, 2, it's going to be 12, 30, and then copy it down from here, 1, 3, up there. And I'm going to do exactly the same thing. I'm going to find the determinant of this matrix. 12 times 3 is 36 minus 1 times 30 is 30 So x is 6 over 1. Fantastic. Alright, now I want to solve, we know what x is, so we could theoretically just sort of cut and paste this there onto that. But let's kind of repeat this whole step again, and let's do it for y. So I'm going to take this original matrix, and on top of the y values I'm going to put the 12 and the 30. I'm going to do it, let's do it down here. 1 and 2, so that stays there now, and now 12 and 30 appear. Same thing. 1 times 30 minus 12 times 2. So 1 times 30 is 30 minus 12 times 2 is 24, and that's 6. So y is 6 over 1, which is 6. And that's our answer. If you remember, this is the apples and oranges. Is it the apples and oranges? Yes, it is the apples and oranges example. And there we worked out we were going to buy 6 apples and 6 oranges. And sure enough, that's what we find there. Let's do another one. Okay, first thing we need to do is create the original matrix. So our original matrix, we're going to take the coefficients there. It's in the form y, x, and then constant. So 3x, 2y, 2x, 3y, right? And then 410 over 440. Fair enough. Okay. We do exactly the same thing there. Here we go. So 3 times 3 minus 2 times 2. That's 9 minus 4 is 5. So I'm going to put there x equals something over 5 and y equals something over 5. Now I want to solve for x. So this is the x column, this is the y column, and I'm going to sort of cut and paste this 410 and 440 on top of that. So 410, 440, and the y's carry down, 2, 3, and I'm going to do exactly the same thing. There's no art involved, you just put in the numbers and it gives you an answer. Okay, 410 times 3 minus 440 times 2, so that's going to be what, 1230 minus 880. Let's grab the calculator. So I'll put the whole thing in. Times 2. And it's going to give us 350. So I'm going to put 350 up there. So x is not 350, it's 350 divided by 5. So 350 divided by 5, 70. So x is, in fact, 70. Now let's do the same thing for y. So I'm going to copy down the x values from up up in this one, and then I'm going to cut and paste the 410 and 440 down there. Yes, that's going to work. Do that just to show that we're multiplying. Start from here, subtract. So our answer for this one is going to be 3 times 440 minus 410 times 2. I don't know what that is off the top of my head. 3 times 440 minus 410 times 2, 500. There we go. So y is 500 divided by 5. You shouldn't really need a calculator for that. It's 100. So x is 70, y is 100. And let's test it out. Go to menu, simultaneous equation, solver, 3, 2, 410. If you see up here, it's pretty much doing the same thing that we did before. This is what the calculator is doing. It's just using Cramer's rule. 2, 3, 440. Solve 70 and 10 and 100. Okay, let's just do one more. Let's do the original matrix. 2, 4, 3, and 2, 75 and 110. So 2 times 2 minus 3 times 7, so 2 times 2 is 4, minus 12 is minus 8. Okay, so x is something divided by minus 8, and y is something divided by minus 8. So now I want to solve for x, so I'm gonna sort of cut and paste over the x column there, and it's going to be 75 over 110, 3 and 2, same thing. 75 times 2 is 150 minus 3 times 110 is 330. So 150 minus 330. Whoops. $150 minus 330 is minus 180. So x is minus 180 divided by minus 8 gives us positive 22.5. Which is what we read. I think from memory that's the cinema or the concert tickets one, and that is the adult cost. Okay, let's find the child cost. So let's find the y. So I'm going to go 2, 4. The x is going to be the same. The y now is going to be the 75 over 110. So 2 times 110 is 220. 75 minus 4 is 300. So 220 minus 300 is minus 80. So y is going to be minus 80 divided by minus 8, and that's positive 10. If you remember, yeah, from memory, the children's tickets were $10. The adults tickets were $22.50. That's it. That's how it's done.